In this video, we will discuss how to use chi-square test in analyzing data. So chi-square test is commonly used for testing relationships between categorical variables. So when we say categorical variable, these are variable that has values that you can put into a countable number of distinct groups based on a characteristics. So for a categorical variable, you can assign categories, but the categories have no natural order or there is no ranking at all. So let's try to apply chi-square in this problem. Determine if there is a significant difference in the preferred subjects of senior high school students. So the first thing that we will do is we need to encode the observed frequency or the actual responses of the respondents. So, in our case, there were 46 students who expressed that they prefer general physics, 50 of them prefer general chemistry, and 60 of them prefer general biology, a total of 156. Now, the next thing that we will do is we need to determine the expected frequency. And for us to determine the expected frequency, all we need to do is we need to divide the total number of responses. In our case, we have 156 divided by the total number of groups. In our case, we have 1, 2, 3. So we have 3 groups. Therefore, our expected frequency is 52. So let's encode 52 in all categories. Okay. Now, the next thing that we will do is to determine now the p-value. And for us to determine the p-value in a free cell, let's type equals chi s q dot test, open parenthesis. So for the actual range, all we need to do is to highlight the observed values. Then let's place a comma. And then for the expected range, all we need to do is to highlight our expected frequency. And then let's end it with a close parenthesis. Then let's press enter. So this is our p-value, or we can round off this into 3 digits. That is 0.368. Therefore, our p-value is 0.368. This time, let's try to determine our test statistic value. And for us to determine our test statistic value, all we need to do is we need to type in a pre-cell equals CHISQ dot INV dot RT, open parentheses. For the probability, let's just click our p-value, which is 0.368, comma. Then for our degrees of freedom, all we need to do is we need to subtract the total number of groups with 1. So in our case, we have 3 minus 1. So our degrees of freedom here is 2. And let's close it with a close parenthesis, then press enter sign. And so this is our test statistic value, or we can round off this to 2.00. Now this time, let us test our statistical hypothesis. So we need to state the null and our alternative hypothesis. So our null hypothesis states that our observed frequency is equals to the expected frequency, whereas our alternative hypothesis tells us that the observed frequency is not equals to the expected frequency. Then the next thing that we will do is we need to set our alpha level. In our case, we will set it to 0.05. Now, setting alpha at 0.05 will indicate that we have 5 chances in 100 of committing type 1 error. When we say type 1 error, this is the mistaken rejection of the null hypothesis. Then, we are ready to make our decision. Now, take note that if our p-value is greater than alpha 0.05, then we failed to reject the null hypothesis. While if our p-value is less than alpha 0.05, then we reject the null hypothesis. Now, in our case, looking our test statistic value and p-value, we can say that in this problem, result obtained a chi-square value of 2.00 with p-value of 0.368. Since the p-value is greater than alpha 0.05, then we fail to reject the null hypothesis. Thus, we can say that there is no significant difference in the preferred subjects of the senior high school students.